So the next question we have answered in our research is, how much water is consumed in the entire United States for light-duty vehicle transportation, and how can we envision how much this may change in the future? In part 1 of this podcast, we discussed the water needed for different parts of the supply chain of making fuels by dividing the water requirements per unit of fuel by the miles traveled per that unit of fuel, such as miles per gallon of gasoline. We obtain the gallons of water consumed and withdrawn per mile traveled. By then using this result and multiplying it by the number of miles driven on each fuel, we then obtain an estimate for the total water consumed and withdrawn for travel in light-duty vehicles for the entire United States. In order to get to this final water total for transportation, we look at what fuels are used today and what fuels might be used in the future. In 2005, light-duty vehicle transportation was almost completely dominated by petroleum, gasoline, and diesel. Some ethanol, blended up to 10% in volume into gasoline, was being integrated as an octane booster. The contributions of all other fuels to the 2.7 trillion miles driven by light-duty vehicles were insignificant. To think about the future in terms of miles driven on different fuels, we look at two different projections to the year 2030. The first is from the Annual Energy Outlook of 2008 that is provided annually by the Energy Information Administration of the Department of Energy. The second projection is derived from a study performed at the National Energy Technology Laboratory, and it examines a scenario and with a much more diverse set of fuels. For both scenarios, it is assumed, as is same in the Annual Energy Outlook for 2008, that 4.1 trillion miles will be driven by light-duty vehicles in the year 2030 compared to the 2.7 trillion miles in 2005. As can be seen from this graphic, 70% of the miles are still based upon petroleum. Approximately 4% of the miles are assumed driven on diesel made from coal, and approximately 20% of the miles are assumed to come from biofuels due to the Renewable Fuel Standard mandates that are in the Energy Independence and Security Act of 2007. If we now look at the more diverse scenario, the National Energy Technology Laboratory scenario, it assumes that 20% of the miles are driven on conventional petroleum in 2030, with 30% of these miles are based upon unconventional fossil fuels, primarily coal to liquids and oil shale. The miles driven on electricity and hydrogen, represented here as non-liquids, are approximately 10% of the total. And biofuels make up the remaining approximately 40% of total miles. This includes gasifying some biomass into liquid fuels in a process similar to that used for coal. So now we've looked at gallons of water per mile, and we looked at the total miles traveled in the United States. So the final step is to combine these two results to estimate the water consumption for light-duty vehicle travel overall in the United States. For 2005, the total water consumption was approximately 4,000 billion liters per year, or almost 1,100 billion gallons. This quantity is over 75% related to corn ethanol blended into gasoline, with the rest associated with petroleum mining and refining itself. By 2030, the low diversity case of the Annual Energy Outlook shows that over 90% of the 14,000 billion liters, or 3,700 billion gallons of water, are consumed related to biofuels. There is a small quantity of water consumed for coal-based liquids. The main driver for increased water consumption is due to the biofuels that are mandated by the Renewable Fuel Standard and assumed to be irrigated at similar rates as today. The Renewable Fuel Standard mandates that 36 billion gallons of biofuels are to be produced by 2022, of which 15 billion gallons can be corn-based ethanol. The corn ethanol limit is assumed to be reached between 2010 and 2015 in our study, and thus its contribution does not increase in the water consumption for light-duty vehicles after 2015. The total quantity of water consumed in 2030 under the more diverse fuel scenario outlined by the National Energy Technology Lab is approximately the same as with the previous Annual Energy Outlook projection at approximately 14,000 billion liters in 2030. In this case, just over 80% of all the water consumed for travel is associated with biofuels, and we see that the water associated with coal to liquids, oil shale-derived gasoline, and electricity for electric vehicles now show up on the graphic. Again, even though the oil shale indicates a relatively small amount of water at 300 billion liters a year, the impact will be felt locally at the mining location, and local water resources must be sufficient in quantity and be maintained with proper quality. Contrast that localized mining effect with the 170 billion liters consumed for electric vehicle travel in 2030, which will be highly dispersed among the thousands of power plants across the country. So in summary, approximately 4,000 billion liters of water were consumed in 2005 for light-duty vehicle travel, or about 3% of the U.S. total water consumption. By 2030, this quantity could be 10% of total consumption. The problem is that the last time the USGS reported a country-wide value for total water consumption was in 1995. Thus, we are comparing the values we are approximating for the future with consumption data that is 15 years old. However, we can say that water consumption for transportation is likely already more than for the electric power generation sector at 3 or 4% of the total U.S. water consumption. We have essentially been using our domestic water resources to substitute for foreign oil imports, and biofuels are now a subset of the largest water-consuming sector, which is agricultural irrigation. Listed here are a few of our publications on the topic of water requirements for transportation. Thank you for listening.
Feel free to come back to our website, weberenergygroup.com, for more updates on all our students' research, our latest publications, and the things we're up to these days.